Hello everyone, and welcome back to the Fluctus Channel. Hunting submarines is not an easy task. Where do you even start? Fortunately, the US military has a way to hunt and destroy submarines from an advanced plane. During World War II, the USS Guadalcanal was instrumental in the fight against submarines. It was the first time a US Navy ship had ever captured an enemy submarine at sea when the USS Guadalcanal Task Group took the German submarine U-505 on the 4th of June, 1944. Important information regarding German submarine operations and cryptography was obtained by the Allies through this capture. Boeing designed the P-8 Poseidon maritime patrol aircraft based on the 737-800 airliner. The US Navy and other countries utilize it for anti-submarine and anti-surface warfare, as well as intelligence, surveillance, and reconnaissance tasks. The P-8 has modern sensors and weapons such as radar, sonobuoys, harpoon missiles, and torpedoes. Poseidon is a dedicated anti-submarine warfare aircraft.
The reason why it's important to the fleet is it's the eyes and ears of the fleet and the fleet commander. So if there's anything that is of concern to the fleet commander, he's going to send out that P-8 to figure out what's going on for him and for his team. And then ultimately, we become part of the solution, all the way through the kill chain, finishing whatever target is required.
Let it ride out, let it ride out.
The P-8 Poseidon undergoes pre-flight testing and maintenance to ensure it is mission ready. The maintenance staff does rigorous examinations of fuel levels, hydraulics, avionics, sensors, and weapon systems. They inspect for leaks, wear, and appropriate operation, and make any necessary repairs or replacements. The aircraft commander and crew then go through their own pre-flight checklists, checking vital systems like navigation, communication, and flight controls. This joint approach by maintenance professionals and flight crew ensures the P-8 Poseidon's readiness for safe and effective mission deployment. After takeoff, the pilot follows a flight plan. A typical P-8 ASW operation involves identifying and tracking submarines in a certain area. The P-8 uses sonobuoys, acoustic sensors that receive and broadcast sound waves, to form a wall of sound surrounding the suspected submarine location. The sonobuoys detect acoustic characteristics, such as propeller noise or machinery sounds, which are then evaluated by the P-8's onboard systems to establish the submarine's location, speed, and direction. If offensive action is required, the P-8 can launch torpedoes or depth charges against the submarine. The P-8's powerful sensors and processing systems allow it to identify and track submarines in a wide range of conditions, and its ability to communicate with other aircraft enables coordinated responses to submarine threats. Poseidon can stay on station for 4 hours, but it still needs to refuel every so often. A KC-135 stratotanker is used in this case. The aircraft approach one another head-on. At about 18 to 20 miles separation, the KC-135 turns away from the P-8 with 1,000 feet vertical separation. And the Poseidon chases and catches up with the stratotanker. When the P-8 reaches the tanker, it remains at about 50 feet away, which is the pre-contact position. Also known as the boomer, the flying boom operator controls the connection with the refueling nozzle. Control over the boom is exercised by the boomer with a joystick throughout the 900-gallon-per-minute refueling process. After disconnecting, the P-8 continues its mission. In the US military and NATO, various ways exist to find and destroy submarines. Submarines are detected and destroyed utilizing advanced sonar equipment, sonobuoys, and aircraft support. Sonar operators on surface warships identify submarine acoustic fingerprints, while sensor operators use sonobuoys to improve detection accuracy. Helicopters like the Spanish Navy Seahawk 60B Toro are loaded with sonobuoys. And then these helicopters, equipped with sonar and torpedoes, are launched to detect and engage submarines. When a submarine is discovered, the helicopter or surface vessel can discharge torpedoes to eliminate the threat. Continuous coordination among sonar operators, sensor operators, and aerial units guarantees that hostile submarines are tracked and destroyed and the kills confirmed. Another means of finding and neutralizing submarines is by using unmanned systems. One of the major issues with these types of systems has been underwater communication. Establishing dependable communication networks is critical for various purposes, including military operations. However, standard communication devices used on land are ineffective underwater, creating a huge barrier. Given that water covers the majority of the Earth's surface, creating a standardized digital underwater communication system is critical. To meet this demand, researchers have been developing a common standard for underwater audio communications. Recently, A breakthrough was made with the introduction of a standardized protocol called JANUS, which has been acknowledged internationally. This milestone represents a substantial advancement in enabling effective underwater communication, paving the path for a wide range of applications and advances in this field.
The research focus of CMRE is to do ASW using a network of autonomous platforms, autonomous underwater vehicles, autonomous surface vehicles. And the idea is that together, by sharing information, by processing their detections, their contacts, their tracks jointly, they can achieve great performance. And necessary to that is the two vehicles communicating, and communicating with the Alliance and communicating with the surface platforms.
Unmanned underwater vehicles, like Slocum underwater gliders, are self-contained battery-powered devices designed to collect oceanographic data over long periods of time and across huge distances. Named after Joshua Slocum, the first person to sail alone worldwide, these gliders exploit buoyancy fluctuations to glide across the water in a sawtooth pattern, conserving energy and allowing for long-duration missions. Slocum gliders are critical in anti-submarine warfare because they provide continual underwater reconnaissance. They are equipped with various sensors to detect underwater acoustic signatures, collect environmental data, and transmit information to surface ships or command centers. This data contributes to more accurate simulations of the underwater environment, as well as improved sonar performance and submarine detection capabilities. Training with Slocum gliders entails familiarizing ASW personnel with the deployment, navigation, and data gathering procedures. Operators learn how to program mission parameters, monitor glider performance, and interpret data to make informed ASW decisions. The JANUS Underwater Communication Protocol enables Slocum gliders to communicate and share data easily with other underwater assets and surface boats. This interoperability is critical for ASW operations that need real-time data sharing and situational awareness. Submarines are not the only threat to surface vessels. Aircraft and anti-ship missiles also must be dealt with. Loading a rolling airframe missile, RAM, into the launch systems of WASP-class ships such as the USS Baton is a precise and coordinated process. The RAM is moved from the magazine to the launcher with specialist handling equipment. Technicians secure the rocket in the launcher canisters, ensuring appropriate alignment and connections. The RAM is primarily intended for close-in defense, intercepting and destroying incoming anti-ship missiles, airplanes, and other aerial threats. Its superior infrared and radar-guided technology, as well as its quick reaction time, make it a critical component in defending the vessel and its strike group from close-range airborne threats. Submarines pose a significant threat to ships. Therefore, the US military and NATO developed, tested, and trained in the best systems, such as the P-8 Poseidon. Thanks to reliable radio control, UUVs are now more accessible. As technology continues to evolve, the integration of manned and unmanned systems ensures that navies can detect, track, and defeat threats across every domain, keeping sea lanes secure in an increasingly complex maritime environment. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.